I'm Mike Barley with Electric Lab. For some time, I've been wanting to do a video on the subject of residential electrical systems. So here we go. This video, which will likely be in at least two parts, will cover subject matter from the origin, the history of residential wiring, aluminum versus copper, residential codes, lighting outlets, non-metallic sheath cable, GFCI, AFCI, wire sizes and wiring procedures, and fire alarm systems in the residential sector. So a great deal of information here and a lot of material to cover. So let's get started. Okay, so we're going to start with some origin story. And as you can see here in our very first slide, there's a lot of different type of residential structures, from the $1 million home to the, as we call them, tract homes, older homes, where we might be doing renovation work. Lots and lots of work in this sector. And a lot of variety in styles of homes. So the earliest wiring systems used in an open wiring system, one that remained in use from the 1880s through the 1930s and was commonly called knob and tube wiring. So as you can see in the pictures there, that is knob and tube wiring. Single conductor, it's not in a cable, single conductor that is run through the joist or the studs and is held with a porcelain knob is essentially what that is. You can see there's sleeves that actually go up through the plate to protect the wire as it goes through it. And splices are made just in midair, you would call it. At splice locations, the splice connection was soldered and wrapped with insulation tape. And I used to work for a contractor that actually made splices like that back in the day. And this was probably in the 1980s, I would say. And we did use soldering to make our splices. And, obviously in the 1980s, wire nuts were already around. And he just advertised it as we make the best splices in town. And we did. But you didn't want to make a wrong joint, because taking a solder joint apart was a nightmare. And you can see there, though, where they're all taped up. And, in this case, it may not be soldered. It might be just a wire that's literally wrapped around it and then taped up. There were no grounding requirements in early wiring. In both the late 19th century and early 20th century, branch circuit grounding was considered a hazard. Isn't that strange? Utility companies used grounding for their systems, but once power entered a home, the wiring was a simple two-wire system, and grounded outlets and circuits would not be required until 1960. As the early 20th century electrical need was for lighting, it wasn't long before other electric inventions became available to the public. One of the first was the electric toaster, first marketed in 1905, although not perfected until 1911. It's kind of funny. The first thing that went after is being able to make toast, huh? By 1925, there were more homes with electrical wiring than with indoor plumbing. Yikes. Harvey Hubble. Oh, Harvey Hubble goes way back. Harvey Hubble invented and filed for 2 patents with 2-pin plugs and adapters for using his plugs with existing designs of lamps and sockets. Gradually, his wall sockets were added to homes to supplement the light socket adapters that screwed into the lamp holders. Official standardization of receptacles and other components occurred in 1926 when the National Electrical Manufacturers Association, better known as NEMA, was founded. And you can see here in the picture, there's a wide variety of different things here. Initially, the minimum electric service to a home was 30 amps, 120 volt. And I'm in the Louisville and Southern Indiana area, and I remember being in homes as a electrician that, in particular, a certain home in the west end of Louisville that had only a 30 amp, 120 volt service going to it. They only had one leg. The first solenoid voltage tester was developed by George Wigington in 1918. Solenoid testers today are still referred to as Wiggies. I still have a set of these. I'm sure there's others that do. There's definitely been some shade thrown on this type of testing equipment these days. Typically I believe you're using a multimeter or a digital multimeter. Knob and tube wiring systems began to be phased out in the 1930s, probably because of the growing use of rigid conduit. Unlike the old black iron pipe, galvanized rigid had a much smoother interior and was faster to install than knob and tube. Another reason knob and tube was phased out was the introduction and popularity of the first non-metallic cable and armored cable systems. These advancements in wiring were less labor intensive and eventually led to the end of knob and tube systems use. However, it is still described in the NEC in Article 394 for dealing with existing installations. I mean, obviously, the code has to continue to provide guidance for systems that we know are still in use, even though they're no longer applied. For example, branch circuit old technology aluminum wiring, which is back in the 1960s, they were making Romex that had just simply aluminum in it, not copper clad, simply aluminum in it. Now, metallic sheath cable, what was first listed and in the NEC in 1926. It was developed and patented a few years earlier by General Cable in their Rome wire division located in Rome, New York, and originally marketed under the trade name Romex. And as you can see in the picture here, that's the classic Romex. That's a cloth insulation on the outside of it rather than the plastic as we see today. Originally, NM cable had the individual conductors paper wrapped in a jacket of a spun cotton braid. The braid was then impregnated with thin coal tar for moisture protection. In fact, coal tar has been used for moisture protection for over 700 years. In 1951, synthetic rayon began to replace the cotton thread in the jacket braid. In the early 1960s, thermoplastic began replacing the braided jacket altogether. Braided NM covering was still permitted until 1984. Also in 1984, the next generation of cable was introduced. NMB cable was developed and required a 90°C rating of individual conductors and a 75°C outer jacket rating. Armored cable, or type AC. This was first listed in 1899. It was originally called Greenfield, named after its inventor, Harry Greenfield. He made two types, AX and BX. The X stands for experimental. It was the BX version that ended up being produced. And I've seen lots of this in a lot of older homes. An EMT conduit. And just let me say on the side here, check out our video on conduit bending on our YouTube site. Goes on about the history of Jack Benfield and some of his antics working in the field, teaching people how to bend conduits so they'll start using EMT. It's very interesting. But EMT was slow to become commonly used as the bending process needed both a growth and an understanding of the product. Not until the 1930s when Jack Benfield developed the mathematical process of bending angles and applied his method to the markings on the first reliable bender, the Benfield bender. He would travel around to cities and teach electricians how to use his product and then sell them his benders. So what's conduit got to do with residential? Well, today, for example, NM cable is not permitted to be used in Chicago or New York for residential installations. Conduit is the preferred method. And I'll say I used to have a colleague that was out of Chicago area. He was a retired union worker, actually an educator in the union trade. And I asked him once, so why do they require conduit and don't allow Romex in Chicago? And he just immediately said, well, it's because of the Chicago fire. Well, from what I hear of history, the Chicago fire supposedly was started by a cow kicking over a candle or a lamp in a barn or something, and that ended up catching the whole city on fire. I'm not really sure what that has to do with Romex, but anyway. Now, aluminum versus copper. By 1952, the country had its second major copper shortage due to the Korean War. During WW2, the only allowed conductors at the time were copper, gold, and silver. Aluminum was expensive to manufacture and it wasn't considered a good conductor. With the advancement in processing and production of aluminum as a conductor, a code change was promoted in 1942. The copper shortage of the 1960s was primarily caused by the U.S. government, which had huge contracts out for air conditioning coils. This promoted the first real demand for aluminum conductors. The problem was the wire itself. Prior to 1972, the wire was inferior and had tremendous expansion and contraction issues. The outlets were made of similar metals and that causes oxidation. Oxidation of aluminum causes aluminum oxide, which becomes an insulator instead of a conductor. This combination caused innumerable fires, burnouts, and deaths. Thus, aluminum wiring received a very bad reputation. I had someone tell me once that when you would get a roll of, let's say, 10-2 aluminum Romex, you might, if you used your wire strippers to size that conductor, it may be a number 10 at this end of the wire, but as it went through that roll of wire, if you checked the circular mill area on that conductor halfway through, it might go down to only maybe a number 12 or a number 14, and then it'd go back up to number 10. Yeah, they had some real manufacturing issues with that now. Today, we're seeing a big push of copper-clad aluminum in our trade. That's for another video and another subject, but we're seeing a big push in that in the code. Modern aluminum wire is AA8000 series alloy of a higher tensile strength, so it stays tighter and reduces the expansion and contraction. And I've seen some reports that they say that you no longer need to use deoxidizer inhibitor on aluminum wiring. I think if I were an installer, I'd still be doing it because I would not be sure whether or not the inspector knows that. The modern residential electrical system. So here's some of the areas that are, I would call the expansion in this system. You know, it used to be you went in and the circuits were very simple. The electrical systems were very simple. I believe that the residential installer in the electrical world today can't just be a wire jockey, as they say. You're going to have some technology smarts about you to be able to install some of this new tech that's coming and is even here. So branch circuit wiring systems for arc fault and ground fault protection, surge suppression for protection of sensitive electronics, alarm systems, fire, burglar, carbon monoxide, data and communication, audio and video systems, energy management systems, keyless access systems, smart home systems, backup generator systems, and of course, green energy systems, photovoltaics, and wind. Today's residential electrician must have an even higher level of skill set to be prepared to meet the demand of systems installations in a home today. Green energy, smart systems, and energy management are no longer just for the commercial structure and application. Wiring basics. Article 210.52. So Article 210.50 required outlets. Receptacle outlets shall be installed as specified in 210.52 through 210.64. Article 210.52 dwelling unit receptacle outlets. General provisions. So here's the grocery list of places. In every kitchen, family room, dining room, living room, parlor if you got one, library, den, sunroom, bedroom, recreation room, or similar room or area of dwelling units, receptacle outlets shall be installed in accordance with the general provisions specified in 210.52 A1 through A4. Spacing. So receptacles shall be installed such that no point measured horizontally along the floor line of any wall space is more than 6 feet from a receptacle outlet. Kitchen receptacle requirements. 210.52B1, small appliances, receptacle outlets served. So receptacle outlets served in the kitchen, pantry, breakfast room, dining room, or similar area of a dwelling unit. The 2 or more small appliance circuits required by 210.11 shall serve all wall and floor receptacle outlets covered in 210.52A, all countertop outlets covered by 210.52C, and receptacle outlets for refrigeration equipment. So you're required to have 2 small appliance circuits in the kitchen. That's the code minimum. You can have more than that, but that is the bare minimum. And in most kitchens today, the only scenario I can see me only installing 2 of them is maybe if it was an apartment building, an apartment unit, and it's a galley style kitchen, very small kitchen, only a handful of receptacles. I can see that probably flying, but other than that, most kitchens are going to require more than that. Receptacles installed in a kitchen to serve countertop surfaces shall be supplied by not fewer than 2 small appliance branch circuits. Countertops and work surfaces, kitchen areas and pantries, breakfast rooms, dining rooms, and similar areas of dwelling units, receptacle outlets for countertop and work surfaces shall be in accordance with that article. And wall countertop and work surfaces, this is location, location, location. A receptacle outlet shall be installed at each wall countertop and work surfaces that is 12 inches or wider. In other words, if you have a counter space that is 12 inches or wider, you got to have a plug on it. Receptacle outlet shall be installed so that no point along the line is more than 24 inches measured horizontally from a receptacle outlet in that space. Why? Because most appliance cords are that comes on your air fryer, or your toaster, or what have you, are very short. Now, I'm going to go through this and then explain a little bit further beyond it, but it says island countertop spaces. At least 1 receptacle shall be installed at each island countertop space with a long dimension of 24 inches or greater and a short dimension of 12. Peninsulas, kind of the same thing. Per the 2023 National Electrical Code, not required. Now, what that means is, and the code in the 2023 states that it is optional. So you can install one if you want, but if you do install one, you cannot install it on the side of the cabinet. That is no longer code legal. The reason is that the Consumer Product Safety Commission stated they had record of over 7,000 injuries, predominantly children, who had accidentally pulled a crock pot or some sort of piece of equipment, appliance or something, over on themselves by pulling on the cord. Those outlets now are required to be in the countertop, and there's some new types out. I don't know that they're new, but receptacle outlets that pop up that you can put on the countertop now that are to be used in that application. Or you simply are not required to install them. But if you do not install them, what is required is that you will run a wire to that area and either leave it curled up underneath it, maybe in the basement, or crawl space, set a junction box on it or something like that, and mark it for future use, or pull it up into the cabinet and set a junction box on it. And for example, let's say you're doing a patio home. So yeah, you're going to have to put a pipe in the slab, get a wire stubbed up over there for it, just so you can put a junction box on the end of it. Again, it is code legal to put one in the island, but it cannot be on the side, and it is not required. It is left to be optional. Separate spaces. Countertop spaces separated by arranged tops, refrigerators, or sinks shall be considered as separate countertop spaces in applying the requirements of 210.52C1. If a range countermounted cooking unit or sink is installed in an island or peninsula countertop and the depth of the countertop behind the range countermounted cooking unit or sink is less than 12 inches, the range countermounted cooking unit or sink shall be considered to divide the countertop space into 2 separate countertop spaces. Each separate countertop shall comply with the applicable requirements of 210.52C. Now, receptacle outlet locations. The receptacle outlet shall be located on or above, but not more than 20 inches above the countertop or work surface. Receptacle outlet assemblies listed for use in countertop or work surfaces shall be permitted to be installed in countertops or work surfaces. Receptacle outlets rendered not readily accessible by appliances fastened in place, appliance garages, sinks, or range tops as covered in 210.52C1 exception, or appliances occupying dedicated space shall not be considered as these required outlets. You know, the classic appliance garage in the corner, you got to plug inside of that, it's not considered accessible. And you can't put receptacles, the receptacles that might be mounted maybe up in a cabinet or up higher than 20 inches are not a part of that count. And I have installed receptacles along countertops that maybe they had a really nice backsplash and they didn't want to put plugs in it. So what we did was we actually used plug mode and ran it underneath the light rail of the cabinet, and that was sufficient, code compliant. And here's a little graphic of a kitchen layout. You can see those receptacles there in purple to the left, and along with the receptacles up on the counter space on both sides, all required to be on the small appliance branch circuit. Bathrooms. At least one receptacle outlet shall be installed in bathrooms within 3 feet of the outside edge of each basin. The receptacle outlet shall be located on a wall or partition that is adjacent to the basin or basin countertop, located on the countertop, or installed on the side or face of the basin cabinet. In no case shall the receptacle be located more than 12 inches below the top of the basin. I wouldn't be surprised if that gets changed over time. You really kind of run into the same problem as you would with a receptacle on the island in the kitchen. Quite frankly, the island and the kitchen in this are one and the same when it comes to a receptacle on the side and somebody pulling a hot curling iron or something like that down on themselves. And here you have two sink basins in this bathroom, so per sink basin there ought to be a receptacle. Outdoor outlets, essentially this, you're required to have a outdoor outlet on the front and the rear of a single family dwelling, and if you have an air conditioning unit on the outside of the house, you're required to have a receptacle within 25 feet of that air conditioning unit. Now, let's say you have a receptacle on the front and the rear of the house, and your air conditioning unit isn't within 25 feet of that receptacle, then you're good to go. You only have to have two. But if not, then you would have to have that third outlet. Laundry areas. In dwelling units, at least one receptacle outlet shall be installed in areas designated for installation of laundry equipment. Basements, garages, and accessory buildings. Essentially, in garages, it used to be, let me be clear on that, it used to be that you could have a 4-car garage and you were only required to put one plug in there, which is kind of crazy. Now it is per car space. If you got a 3-car garage, you got to have at least 3 receptacles in there, 1 per car space. Accessory buildings, of course, in each building that has electric power. And in each separate unfinished portion of a basement area, you need to have a receptacle. So if you got a big finished basement, but you have a utility area or a separate area that's just storage and it's all just like you see here, concrete walls, you're required to have one in that area. Hallways. In dwelling units, hallways 10 feet or more in length shall have at least one receptacle. Foyers that are not part of a hallway in accordance with 210.52H and that have an area that is greater than 60 feet square shall have a receptacle located in each wall space 3 feet or more in width. Doorways, door-side windows that extend to the floor and similar openings shall not be considered wall space. Lighting outlets. So Article 210.70, lighting outlets required. So in dwelling units, lighting outlets shall be installed in accordance with 210.70 A1, A2, and A3. Habitable rooms, got at least one wall switch controlled lighting outlet shall be installed in every habitable room, kitchen, and bathroom. You're required to have those, and so you can turn a switch on. And I've done a lot of work in older homes where if they were old enough, they may have had just a pull chain light that was in the middle of the room, big long string on it. That was it, no switch. Additional locations. At least one wall switch controlled lighting outlet shall be installed in hallways, stairways, attached garages, and detached garages with electric power. For dwelling units, attached garages, and detached garages with electric power, at least one wall switch controlled lighting outlet shall be installed to provide illumination on the exterior side of outdoor entrances or exits with grade level access. A vehicle door in a garage shall not be considered as an outdoor entrance or exit. And where one or more lighting outlets are installed for interior stairways, shall be a switch at each floor level and landing level that includes an entry to control the lighting outlet where the stairway between floor levels has at least 6 risers or more. So in other words, if there's 6 steps or more, you need to have a set of 3-way switches on that stairway. Back in the 80s, I used to do a lot of what are called bi-level homes, and they would have a very short stairwell, maybe only 3 to 4 steps, maybe 6 steps. And it was kind of borderline. Do you have to have a 3-way? You know, of course, we always put them on it, but areas like that are kind of border. Let's say you've got a basement that you've got a unfinished basement. So You have to have a set of three-ways at the top and the bottom of that stairs, even if it's an unfinished area. Pathway lighting is really what that's called. Storage or equipment spaces for attics, underfloor spaces, utility rooms, and basements. At least one lighting outlet containing a switch or controlled by a wall switch shall be installed where these spaces are used for storage or contain equipment requiring servicing. At least one point of control shall be at the usual point of entry to these spaces, and the lighting outlet shall be provided at or near the equipment requiring service. I have for many years always put lighting up in the attic. That's extremely helpful, and a switch to turn it on to where when you get up in there, you're not fishing around for it. You've got a switch, and always put a receptacle up there to provide power in the event that you ever needed something to plug in up there. Article 410, luminaire lamp holders and lamps. Closet space. This is the trick. Closet spaces oftentimes are labeled as the area where they're concerned about having problems with light fixtures that are too close to shelving, where you may have blankets stacked up on a shelf. I used to do a lot of work in older homes that had a pull chain, bare pull chain incandescent bulb up there. And you can see where somebody could stack a stack of blankets up against that hot bulb. And if you've dealt with an incandescent bulb, you know them bad boys can get pretty hot. Stack the blankets up against that and catch the house on fire. At no time should you put any light fixture inside of a closet that does not have a lens on it. And there's a whole series, if you look in Article 410, there's a whole series of measurements and different things for different types of lights. Predominantly today we're using LED on just about everything. And so any kind of lighting inside the closet should be LED, and certainly should have a lens on it, and should be as far away as possible from any shelving. Oftentimes in the smaller closets, maybe not walk-in closets, I would typically put the light fixture up on the header directly above the door just to get it as far away as I could. Now, I said all that without reading all of this different breakdown for LED lights, fluorescent lights, incandescent lights. Not necessary. Means of support. Outlet boxes or fittings installed as required by 314.23 and complying with provisions of 27 shall be permitted to support luminaires. Suspended ceilings. Framing members of suspended ceiling systems used to support luminaires shall be securely fastened to each other and shall be securely attached to the building structure and at appropriate intervals. Non-metallic sheath cable. Who's that guy up here at the front door? Article 334 of the National Electrical Code is a non-metallic sheath cable types NM and NMC. So NM and NMC and type NMS cables shall be permitted to be used in the following except as prohibited in 334.12. 1- and 2-family dwellings and their attached or detached garages and storage buildings, multifamilies, and other structures permitted to be of types 3, 4, and 5 construction. That's building code related information there. So if you look through Article 334, the number one piece is that you've got areas where it can be used and areas where it can't be used. And where it is, as it says here to the right, exposed work, protection from physical damage. The cable shall be protected from physical damage where necessary by rigid metal conduit, IMC, EMT, PVC. In other words, you can't just run a piece of Romex down the basement wall on a concrete wall. It must be protected by some sort of a conduit sleeve. In unfinished basements and crawl spaces, where cable is run at angles with joist in unfinished basements and crawl spaces, it shall be permissible to secure cables not smaller than 2 6 AWG or 3 8 AWG conductors directly to the lower edges of the joist. In other words, you don't have to drill them out if they're not smaller than that. Smaller cables shall be run either through bored holes in the joist or on running boards. Typically, you're drilling them through the joist. And I'll say this, when you're drilling through the joist in a basement, you never drill directly right down the middle of the basement. You're going to drill no further than 3 feet out from a support wall or the outside basement wall if we're doing that. But those are very specific requirements. They say when you drill out too many holes in the middle of a joist like that, you're destroying the integrity of the beam. Other matters over here, through parallel or framed members, were installed through parallel framing members. Grommets used as required in 300.4 shall remain in place. If you're using metal studs, certainly need to install grommets. Attics, the installation of a cable in accessible attics or roof spaces shall comply with 320.23. There's a whole listing of that. That's not actually spelled out in this presentation. And the bending radius shall be made so that the cable will not be damaged, and the radius of the curve of the inner edge of any bend during or after installation shall not be less than 5 times the diameter of the cable. You don't want to just make loop-to-loops with this stuff and bend it really tight. Use is not permitted. Exposed within a dropped or suspended ceiling cavity other than 1 and 2 family dwelling units. That is allowed in a dwelling unit. Where exposed to corrosive fumes or vapors, embedded in masonry, concrete, adobe, in shallow chase in masonry, concrete, or adobe. Exposed work down here, we have to follow the surface. Cables shall closely follow the surface of the building finish or of running boards. And again, protection from physical damage. Securing and supporting. Non-metallic sheath cables shall be supported and secured by staples, cable ties listed and identified for securement and support, or straps, hangers, or similar fittings designed and installed so as to not damage the cable at intervals not exceeding 4.5 feet and within 12 inches of every cable entry into enclosures such as outlet boxes, junction boxes, cabinets, or fittings. Flat cables shall not be stapled on the edge. And horizontal runs through holes and notches, and other than vertical runs, cables installed in accordance with 300.4 shall be considered to be supported and secured where such support does not exceed 4.5 feet intervals, and the NM cable is securely fastened in place by an approved means within 12 inches of each box, cabinet, or conduit body.